Hey erudites, I am Francis Xavier Javier, one of your lecturers for General Chemistry 1. Today we'll explore something very important in chemistry, the law of definite proportions. By the end of this tutorial, you'll not only understand the law, but also know how to solve the problems step by step. This law was first proposed by Joseph Proust in 1797. Therefore, this is also referred to as the Proust's law. He discovered that copper carbonate, or CuCO3, always had the same ratio of copper, carbon, and oxygen no matter how he prepared it. The law of definite composition, also known as the law of constant proportion, states that a chemical compound always contains the same elements in the same proportion by mass, no matter where it comes from or how it was made. This means that if you have a pure sample of a compound, say copper carbonate or CuCO3, it will always be made up of 51.4% copper, 9.7% carbon, and 38.9% oxygen by mass. So it doesn't matter if the sample comes from nature or a lab experiment, their ratio never changes. So para ka lang nag-bake ng cake, whether it is small or a big wedding cake, the recipe ratio must stay the same or it won't taste like the same cake. Here are the steps in solving problems with the law of definite composition. Use the mnemonic MAP or MAP. First is to find the total mass of the sample. Next is to divide each element's mass by the total or the atomic proportion. And finally, multiply by 100 to get the percent composition. Let's now solve problem 1 using MAP. A 150-gram sample of baking soda contains 62.99 gram of sodium, 24 grams of carbon, 36.01 grams of oxygen, and 27 grams of hydrogen. What is the percent by mass of each element in baking soda? First step is to find the total mass of the sample. In this problem, the total mass is already given, but in instances where it is not provided, you should add up all the mass of the elements to get the total mass of the sample. Next, let's get the atomic proportion. This is done by dividing each element's mass by the total, after which you multiply it by 100 to get the percent composition. Now let's do that for all the elements given. And you could also present your answers in a table format shown here. Now, if you're wondering, do the percentages always have to add up to 100%? The answer is yes, because the total mass of all the elements equals the total mass of the compounds. All the parts must add up to the whole or 100%. Let us solve another example to check the law of definite composition. For problem 2, we have two samples of pure water, one from a spring in Laguna and another collected from a rainfall in Quezon Province. Sample 1 has a mass of 0.500 grams with 0.056 grams of hydrogen and 0.444 grams of oxygen. Sample 2 has a mass of 1.800 grams with 0.202 grams of hydrogen and 1.598 grams of oxygen. Let's plot our values in the given table. For the total mass of sample 1, it was stated that it is 0.500 grams, with the mass of hydrogen being 0.056 grams, and the mass of oxygen being 0.444 grams. For sample 2, it was given that it has a mass of 1.800 grams. For hydrogen, it was 0.202 and 1.598 grams of oxygen. Now that we have our values in the table, let us now proceed to calculate the percent composition for sample 1. For percent of hydrogen, there is 0.056 grams of hydrogen all over the total, which is 0.500 grams, times 100, and this will give you 11.2%. Next, for oxygen, it was given that 0.444 grams of oxygen was present, divided by the total mass of the sample of 0.500 times 100, and you have 88.8%. Now let's do the same thing to calculate the percent composition for sample 2. Sample 2 of hydrogen contains 0.202 all over the mass of sample 2, which is 1.800. times 100 is equals to 11.2%. For oxygen, it was given that it has 1.598 grams of oxygen all over the total mass of the sample, which is 1.800 times 100, which will then give you 88.8%. So both samples give exactly the same percentages, 11.2% hydrogen and 88.8% oxygen. So therefore, no matter where the water came from, the composition remains constant. This proves that the samples obey the law of definite composition. In the last problem, we used the mnemonic map, mass, atomic proportion, and percentage, to get the percent composition of a compound. That was straightforward since we only need to divide the mass of each element by the total and multiply by 100. But for this problem, it's a little different. Let's read it together. A compound contains 4.5 grams of nitrogen and 10.20 grams of oxygen. In a second sample, there are 9.00 grams of nitrogen. How much oxygen should be present in the second sample? In the first statement of the problem, it says here that sample 1 contains 4.50 grams of nitrogen and 10.20 grams of oxygen. So this implies na ang ratio of nitrogen to oxygen is 4.5 grams is to 10.20 grams oxygen. The same thing can be said in the second sample. Nagbigay din siya ng grams of nitrogen na 9.00 grams nitrogen. But this time, ang grams of oxygen natin ay missing. So we'll put there a variable x. So ratios can also be expressed in fraction. So sulat natin as fraction ang 4.50 grams nitrogen all over 10.20 grams oxygen. This is now equal to the second sample given, pero dapat make sure na mag-a-align ang nitrogen at oxygen ng both elements. So kung ang nitrogen given sa first sample ay 4.5 grams, ang 9.00 grams nitrogen ay ilalagay din natin sa numerator since katapat niya ang nitrogen ng first sample. This time, ang oxygen naman sa baba ay missing. So we put there x. Now this becomes an algebra problem wherein you need to find x. For solving x, we cross multiply. So this becomes 4.50 multiplied by x, so simply 4.50x times or equals to 9.00 multiplied by 10.20 grams. Okay, let's bring this together and now multiply. So 9 times 10.20 is equals to 91.8. To cancel out the coefficient, you need to divide it sa number ng katabi ng variable. So 4.50 para mag-cancel yung sa x. So para matitira na lang dito ang x na hinahanap mo at ngayon need mo na siyang i-divide. 91.8 divided by 4.50 gives you 20.4 grams of oxygen. Since x is your grams of oxygen, this is now your final answer for this problem. So, unlike our map method, here we're not finding percentages. Instead, we're applying a proportion equation or yung ratio as fraction na ginawa natin because we are scaling mass ratio from one sample to another. So, that's another key idea of the law of composition. So, hindi lahat ng law of composition ay pinapahanap yung percentages. Minsan, pinapahanap rin kung ano yung proportion ng mass niya. And that is how you solve problems with the law of definite composition. Now, let's check your comprehension.